A very good morning to all of you. So in the today's class, we will discuss about the PVT relationships, work transfer, heat transfer, the change in internal energy and the change in enthalpy of adiabatic process. So it is the topic which we are going to deal in the today's class. So what is the motivation? Why we have to study? So it is essential to know the governing equations of the adiabatic process. That is, what is the governing equation of the adiabatic process? That is, PV to the power of gamma is equivalent to constant, where gamma is equivalent to adiabatic index. And similarly, we have to deal with the PVT relationships, which are very, very important one, not only in thermodynamics, it is also important in the upcoming courses also. And how can you estimate the work transfer, heat transfer, internal energy and change in enthalpy of adiabatic process, because these formulas are very, very important one to find out the important parameters whenever we are solving the numerical problems. And what is the expected outcome of this lecture? That is, you should be in a position to solve any problem based upon the adiabatic process. Now, the adiabatic process means, that is, what do you mean by the adiabatic process? You know, because there is no heat transfer from the system to the surroundings or from the surroundings to the system. That is the meaning of the adiabatic process. And I told you that the governing equation is PV to the power of gamma is equivalent to constant. So here you can see PV to the power of gamma is equivalent to constant, where gamma is equivalent to adiabatic index. So once again, you derive the same equation from the first law of thermodynamics, because you know that du is equivalent to delta q minus is a delta w. So from that you are going to derive. So whenever you are going to derive, so here delta q is equivalent to is a du plus delta w, that is the first law of thermodynamics, and pv to the power of gamma is equivalent to constant, it is the governing equation. How can you represent adiabatic process on the PV diagram? So it is basically represented by a curved line. And in the previous class also, we studied about the constant pressure, constant volume and constant temperature. So constant temperature process is also identified with the help of only the curved line. Then what is the difference between the isothermal process and adiabatic process lines on the PV diagram? Because both are represented by drawing a curved line. Then what is the difference? That is, the slope is different. So the slope is different for isothermal process and slope is different for adiabatic process, though both are represented by drawing a curved line on the PV diagram. So finally, by doing so, we are able to estimate the work transfer during the adiabatic process is equivalent, because it is an expansion process. 1 to 2 is the expansion process, 2 to 1 is the compression process. So this formula is applicable for only the adiabatic expansion process. So we are able to find out the work transfer during the adiabatic expansion process is equivalent to P1 V1 minus P2 V2 by gamma minus 1. So that is the formula by which you can estimate the work transfer during the adiabatic process. So the same thing I have written here, P1 V1 minus P2 V2 by gamma minus 1. So what is the formula for the heat transfer? Because adiabatic means there is no heat transfer. So automatically delta Q is equivalent to 0. So PV to the power of N is equivalent to constant. So how that will be equivalent to adiabatic process means, when we substitute N is equivalent to gamma. So PV to the power of gamma is equivalent to constant. So that is the governing equation in the adiabatic process. So N value should be equivalent to gamma. And similarly, it is very, very important one, that is the PV relationships. So PV to the power of gamma is equivalent to constant. So automatically P1 V1 to the power of gamma is equivalent to P2 V to the power of gamma. So this equation is giving us the information about the relationship between the pressure and value. And the second, the PV relationship. So this is giving us the information about the volume and temperature. Volume and temperature. So that is the T2 by T1 is equivalent to V1 by V2 to the power of gamma minus 1. So there are the three important PV relationships. First one is giving us the information about pressure and volume. And the second one is giving us the information about volume and temperature. Third one is giving us the information about pressure and temperature. So T2 by T1 is equivalent to P2 by P1 to the power of gamma minus 1 by gamma. So that is the pressure and temperature relationship in the adiabatic process. So this is the information about the adiabatic process, because we studied the work, that is P1 V1 minus P2 V2 by gamma minus 1, and Q, that is the heat transfer, is equivalent to 0. and similarly the PVT relationships are also we studied. Now let us solve a problem on the adiabatic process. So just you read the problem. I'm not going to read. So just you read the problem and solve it, because he's asking us about what is the change in the energy, and similarly what is the change in the internal energy. Just you make utilize of the first law of thermodynamics equation and what do you mean by the adiabatic process, so you are able to solve this particular equation, this particular problem. So like that, you should be in a position to solve any problem which is based upon the adiabatic process. So I hope you understood the basic concepts of the adiabatic process. So in the next class, we will discuss about the polytropic process. Thank you very much for listening this particular lecture. Thank you very much. Thank you.